Let's talk about some ways to describe matter. We're going to focus on the two big different sections of matter, mixtures and pure substances for section 4.1. Let's get this down first. For all matter, everything you see around you right now, everything that you're made up of, everything that's sitting on your desk, everything that's home right now, can be usually described as either being a mixture of something or a pure substance. Let's talk about mixtures first because they're probably more abundant. Mixtures are anything that have a variable composition. Okay, so a great example of a mixture would be wood. Wood's composition varies greatly based upon the type of tree that the wood comes from. So an ash tree is going to give you different wood than a birch tree would. Soda. Soda is a mixture. What are the different things in soda? Well, it depends on what type of soda you're drinking. But we could say that all soda, if it's not diet, contains sugar, dissolved carbon dioxide. That's what gives it the fizz. Water. All soda has water. If it's a darker soda, it has something called phosphoric acid, etc. There's other things in there as well. And the next one that I'll talk about is very interesting, air. Air is a mixture. We know air contains mostly nitrogen. It's about 78% nitrogen. Okay, the rest of air is made up of carbon dioxide and argon and oxygen and some other things like water vapor. But just to show you that a mixture can vary in composition, the air that we breathe today is vastly different than the air that was around during the early Earth. Take a look at this. Take a look at the carbon dioxide percentage in the early Earth. 18% of the atmosphere was carbon dioxide. 80% was nitrogen. What's really missing from the pie chart in the lower right-hand corner? Oxygen. There was hardly any oxygen, so you and I couldn't have lived on the early Earth. Luckily, there were plants that came to fruition, that grew, that took in this carbon dioxide and released oxygen, so we actually got oxygen in the atmosphere a little bit later on, and we could do our thing. We could then evolve. So mixtures certainly vary in compositions. Let's look at the other half now, pure substances. Pure substances are either elements or compounds and always have the same composition. Water, great example of a pure substance, okay? If you take a look at the image here on the right side, I've got 6 water molecules. And you all know, I hope, that water is H2O, okay? Water is a compound, meaning it is combined, it is a combination of 2 or more different types of atoms, H and O. So water is always H2O, and water is only H2O. It is never anything else. Water is H2O. So that's a pure substance. Now I have a question for you. What about tap water? Is that a pure substance? No, it's not. See, tap water has things in it, like dissolved minerals. If you have hard water at home, you may notice this by when you take a shower, you see the white scale that kind of comes on the shower curtain. It might be hard to get a lather with your soap. That's because of hard water. There may be pollutants inside of water and other things dissolved into water that make it a mixture. Okay, so tap water is a mixture. But pure water, okay, like distilled water, that's a pure substance. Gold. Gold is a pure substance. I got a picture of a gold-plated Mercedes-Benz, which I thought was pretty sweet. Now, there are different types of gold. You've probably heard of the carats before. All right, so what do those things mean? All right, well, 24-karat gold. That is pure gold. If you have 24-karat gold, every single atom inside of that ring is a gold atom. So that's pretty expensive stuff. Now, as you decrease that carat, so as you go on like 18-karat gold, then it's less. Then you don't have all gold. You might have a little silver in there. Okay, you might have a little bit of copper inside of there as well. And so that now, if you've got anything less than 24-karat gold, it's going to be a mixture. But pure gold is 24-karat gold. Okay, 24 karat. They go 24. They use K for carat. There it is. 24-karat gold. That's pure gold. That is an element, and so it's a pure substance. So we have kind of a difference here. Water is a pure substance, but we call it a compound. Gold is a pure substance, but we call it an element. Okay? So what's the difference between those two? Well, if you can look up at a periodic table, and you can find the stuff on the periodic table, it is going to be an element. All right. If you look at the periodic table and you can't find it up there, I say this stuff, it's a pure substance. Tell me if it's an element or a compound. And you look up at the periodic table and it's not up there, it's probably a compound. So let's give you a little test here. All right, the stuff in the lower left-hand corner here, this silver-looking stuff, this is mercury. You've heard of mercury before. It's Hg. All right, if you find a periodic table, could you find Hg on there? You bet you could. It's on the bottom. It's actually blue. It's a different color than most of the other elements. Okay. So yeah, that itself would be an element because you can find it on the periodic table of elements. See? How about this stuff? CO2, carbon dioxide coming out of a smokestack. Is that an element or a compound? It's a compound, right? It's got two different elements combined. All right, so there you go. Pure substances. Pure substances can be elements or compounds. All right, so we can make a little flow chart here to kind of differentiate between mixtures and pure substances. All right, so all the stuff you're looking at right now in your room, wherever you are, that's matter. Matter can be broken down into mixtures, and we didn't talk about the types of mixtures, but we have two different types of mixtures. We got homogeneous mixtures. Okay, homogeneous mixtures would be something like, tap water is a homogeneous mixture. If you look at it, you cannot see the variability. Tap water looks clear, unless it's like really gunky water. But all in all, tap water is a homogeneous mixture. Heterogeneous mixture. Granite, like a rock you pick up off the ground. You can see the difference in there. Okay, there are different minerals that make up that granite rock. That would be a heterogeneous mixture. It's a mixture. All right. Pure substances, on the other hand, we have two types of pure substances. What are they? Okay, elements, compounds. Very good. Elements, compounds. So elements like sodium. Okay, that's an element. Compounds, sodium chloride. Okay, table salt. Compound. All right. Now, let's think about can we separate these things? Like mixtures and pure substances. Can we separate them? That's a good question. Okay, mixtures may be separated simply by understanding the physical properties of the substance. So we got to define that. What's a physical property? Okay, well, a physical property is one that can change without the substance becoming a new substance. Okay? Density. Density can change. If I've got water and I get it really, really, really cold and it freezes, okay, the density of the ice is different than the density of the liquid water. But guess what? It's still water. It is still H2O. Okay? So if I want to separate out a mixture, if I want to take some mixtures and I want to separate them out, okay, I can do so by looking at the physical properties. So maybe I've got a mixture of, let's say something that freezes at a really, really cold temperature. Maybe ethanol does. And I've got a mixture of ethanol and water, and I freeze the stuff. So the water might freeze out first, and then the ethanol would separate. So I could take the ethanol liquid off the top. Boom, I'd be left with the ice on the bottom, and I just separated those two substances. Melting point and boiling point. Here we go. Let's check this out. All right. If I take a mixture, let's say I've got a mixture of water and ethanol, and I showed this in class, I can actually heat it up. And one of them is going to actually boil quicker. The ethanol actually will. And so I can actually take that ethanol, and I can take that ethanol, and I can actually take it off. So that's what my little apparatus here does. This is what we call a distillation apparatus. All right, so that water is going to boil. That water and ethanol mixture is going to boil. The ethanol is going to come off first. It's going to go up. It's going to come down this little tube called the condensation tube or condensing tube. Okay, we are actually putting cold water through the outside of this tube. And the ethanol then will condense. It'll get colder as it hits that cold water. And again, you saw this in class. And it will drip into the flask. And so in this flask, we will have ethanol. And in this flask, we will have water. Cool, we just separated our mixture. Awesome. Okay, what other ways can we do that? Solubility. Solubility is a good one. And magnetism. And again, we showed both of those in class. All right, how about a pure substance? Can we separate a pure substance? It can be, but you really got to understand the chemical properties of the pure substance. Okay, what's a chemical property? Well, a chemical property is a property that describes the ability of a substance to change. So let's think about water. Can we separate out water? We can, but we have to do so using a chemical process. And think about it this way. A chemical process is really hard to undo. All right? Like baking a cake, for instance. You take all the ingredients of a cake and you toss it in the oven. And there's a whole bunch of chemical reactions that go on. And you take the cake out of the oven, and now you have this nice cake that you want to eat. Now, if I asked you, okay, now go and try and unbake that cake, I don't think you could do it. You can't just do that. So what you just did was a chemical process, a chemical change. Okay. On the other hand, if I ask you to freeze some ice, and you go and do that, and then you come back and you give me the ice cube, and I say, okay, now unfreeze this ice. Could you do that? Sure, you could do that. That's a physical change. That's a physical process. Okay. So if we want to separate out a pure substance, though, we are going to have to do that by chemical means. So water, we'd have to do a chemical reaction, that we could separate it out into its hydrogen and its oxygen. So there's two chemical properties that we can actually look for and try to identify to figure out how to separate these things out. Reactivity is one. So if we can run some type of reaction to figure out how to break apart a pure substance. And the other one would be flammability. Flammability is a chemical property. If something's flammable, we'd be able to ignite it and hopefully be able to separate out its constituent parts. All right. There's your overview of mixtures and pure substances.